Okay, hi everyone. So as you may know, this month is the Women's History Month. So to celebrate this, we are going to talk about women astronomers and their discoveries today. So I'm Nancy Ning, and this is
Claire Williams, and we are both graduate students at the UCLA Department of Physics and Astronomy. Okay, so we're going to be giving like a brief run through of a bunch of really amazing women astronomers who contributed to the field. But first, we thought it would be good to have some background and history and just sort of context of what was going on at the time that the first women we're talking about were working. So this is Harvard College Observatory in 1847. In the 1800s, women were expected to basically devote most of their time and energy to homemaking, having children, and raising children. Getting an education just for the sake of education as a woman was uncommon, and working outside the home was almost unheard of, especially for like upper class people. But traditional expectations of women were slowly starting to change. So there were these 7 sister colleges that were founded kind of as counterparts to the like Ivy League colleges in the US for women specifically, and these began admitting students. The first was in 1837, but then between 1865 and 1889, all the rest of the sister colleges opened. So women were starting to get an education, and especially upper class families that had like the means encouraged their daughters to participate in the sciences. So you'll notice like a lot of the women that had the opportunity to even participate in this research are more like upper class white women in the US. But those colleges lacked behind the like Ivy League men's colleges in terms of funding and like investment in research. So like all the premier astronomical research at the time was going on at total male institutions. So if you wanted to do astronomy as a woman, you had to somehow like get involved with the men that were working at places like Harvard. And just to give you a sense of why I guess it was so frowned upon for women to be doing this in the first place, we have this quote. There was a book published called Sex in Education, A Fair Chance for the Girls that was published by a professor at Harvard, a Dr. Edward Clark, and this was in 1873. Basically, this argued that if women were like doing like mental tasks while they were going through puberty, they would have like some reproductive problems. So he writes, a woman's body could only handle a limited number of developmental tasks at one time. Girls who spent too much energy developing their minds during puberty would end up with underdeveloped or diseased reproductive systems. So if the sole purpose of women in society is expected to be to bear children and raise those children, and the scientific consensus at the time, or people in like the medical field are arguing that like this will be damaging to that purpose, maybe you can start to see why it was very uncommon and very frowned upon for women to do any kind of academic work, especially in astronomy and astrophysics. But now Nancy's going to tell you about a more progressive thinking man at Harvard.
Yeah, so as Claire just mentioned, in the 18th century, 19th century, is a woman's role is largely limited to homemaking and having children. So this man, Edward Pickering, he's a progressive thinker. So this man is very important in introducing women into science and into the astronomy field. So before him, the the astronomers, when they're doing observations, the approach is mostly just looking at the telescopes with their bare eyes, and he think it's a very inefficient way. So instead of just looking at the telescopes and taking notes, he proposed a new type of observation method known today as astrophotography. That is, instead of looking at the telescopes, they took photos on the plates and then look at the photos. So he argued that the human eye tires easily with prolonged observation, so it's not the best method, and the photographs last much more longer, and it's much more efficient. And so Pickering, he planned to take a full sky survey of the night sky, so it was really ambitious. And so he took a lot of data on those plates and compared those plates to see how the celestial objects are moving and interacting over time. And this is a very tedious work, and the amount of data they have is beyond anyone's capacity to process individually. So he needs a lot of cheap labor, and so at the time, since women's role are mostly limited to homemaking and they're less educated, so so he basically hired a lot of women to do this work, to do this, to examine those plates that they took the astrophotography. They took the photographs of the sky. So he employed a lot of female staff at Harvard to do this task, and this get all those women involved in the patriarchal realm of academia, and it was really rare at the time for women to work, so it's really progressive thing, and but the problem is it's also still limited because the work those women did at the time were limited to mostly cleric duties, secretarial tasks. So there's not a lot of the active involvement in academia. And Claire's gonna introduce you more about those women.
Okay, so like Nancy said, Pickering was hiring basically entirely women to analyze these photographic plates of like astronomical data. These women were called computers. So before there were like electronic computers, the job of doing computations was called a computer. And so at the Harvard College Observatory, Pickering had a full staff of women called the Harvard Computers that did all of the data analysis for this first full survey of the entire visible universe. The men who also worked at Harvard called this group of women Pickering's harem. This was a derogatory term used towards them. Again, as Nancy said, men were doing the actual like looking through telescopes, and they didn't want to do this sort of tedious work, and women were not allowed to use a telescope. So this was kind of thought of as a second-rate job in astronomy to be doing. These images sort of visualizing what it looked like are from an episode of the TV show Cosmos that talks about this. So I recommend, if you're interested, to watch that show as well about the Harvard computers. And then here are some actual photographs of these women. Basically, they worked for as little as 25 to 30 cents an hour. They did not make a lot of money, and they just meticulously went through this huge data set of astronomical plates. It was extremely painstaking work. They just took a little magnifying glass and they were scrunched over, like looking very closely at these images. And like I said, this was the first full survey of the entire visible universe, which led to a lot of breakthroughs, as we will talk about. But just to get a sense of the scale of this project and the amount of work that these people did, the Harvard computers compiled more than 2,500 logbooks filled with precise measurements and graphs of the analysis that they did. The catalog contained more than 500,000 glass plate photographs from all over the world that they collected starting in 1850. So this was just an immense amount of work, and they became very talented astronomers in the process. And it's interesting to note that Pickering allowed the women to do their own research projects outside of their, like in their spare time, and their names were sometimes cited as co-authors on the scientific papers. So for the first time, women were being recognized as astronomers in their own right. And so now what we'll do is just go through, starting with some of the Harvard computers and then moving forward to women from the 20th century and even today who have contributed major breakthroughs in astronomy. So Nancy will show you the first one.
Yeah, so so the first woman astronomer that we want to introduce you is Wilhelmina Fleming. So she actually was Pickering's maid and one of the first computers, and she has some really significant work in astronomy. She discovered 10 novas and 59 gaseous nebulae and over 300 variable stars. So this is she had went over a lot of the photographic plates. It was estimated that she actually examined around 200,000 of them. So she really did a lot of work in her career. And in 1889, at the age of 24, she was appointed a full-time staff member at Harvard. So this is really significant at the time. And 7 years later, she assumed responsibility for the increasing number of photographic plates, editing publications from the observatory and hiring new computers. And she was also appointed the observatory's curator of astronomical photographs, and that makes her the first ever woman to hold a title at Harvard University. And you may know her because of this famous discovery. So she actually found the Horse Head Nebula. So on the right here, you can see a very pretty picture, a very pretty photo of this Horse Head Nebula. Oh, and yeah. So Claire's gonna introduce another great astronomer.
So Annie Jump Cannon was another one of the Harvard computers. She, in her career, classified 400,000 stellar bodies and discovered more than 300 variable stars, 5 nova, those are like explosions in space, and 1 spectroscopic binary star, so a system of 2 stars that are orbiting around each other. But one of her greatest contributions was a classification system that she developed based on spectra from stars. And I'll explain a little bit the science behind this. So you may have seen a demonstration sometime where if you take light, so like white light for example, and you put a prism in front of it, the refraction of light through the prism will separate the light into its component colors. So you will get a little rainbow spectrum going from red to violet. And when that happens, we call it a spectrum, when you split light into its constituent parts. And so you could do that for light from a single star. So you take the light from the telescope and you separate it into different colors, creating what we call a stellar spectra. And it turns out that these spectra are incredibly important for astronomers to learn about the stars themselves. And today, we are able to get information about like what elements are present in that star, information about the velocity, like the speed at which the star is moving, and they're very important even now. So Annie Jump Cannon was looking at these spectra, and she developed a classification system based on temperature and spectra of stars. So this is called the Harvard System of Spectral Classification. You might notice many times women astronomers' discoveries do not have their name attached to them, and it's just called the Harvard System of Spectral Classification. But it persists today with few modifications. Basically, it arranges the stars in this non-alphabetical pattern, but they're all assigned a letter. So we go O, B, A, F, G, K, M, with like going from hottest and most massive to coolest and least massive. So O's are like the really hot stars, and M are like cooler, smaller stars. And just to get perspective, our sun is kind of on the like smaller, cooler side of things. It's a G-type star. So this is really important work that has been used ever since she developed it. And yeah, so she did a lot of incredible stuff during her lifetime, but I also looked up some other interesting facts about her. And I learned that she was almost entirely deaf for her whole career while she did this work. She was also a suffragist, and she fought for the right of women to be able to vote, which did not happen until the 20th century. But even today, she is recognized by the American Astronomical Society with the Annie Jump Cannon Award that recognizes distinguished women astronomers and their contributions. So my advisor here at UCLA, Smadar Naoz, is a recipient of this award. So it's good to see that she is recognized now. Okay, and Nancy will continue.
Yeah, so we want to introduce another great woman astronomer here, Harriet Swan. So she was hired to look at variable stars, and she actually found 2,400 of them. She studied the Cepheid variable stars. So here you can see this is an animation showing you this light curve. So on the left you see a light curve of this type of star. So you can see the luminosity of the star varies with time, and this is varying periodically, and the period could be range from hours to days to years, and she discovered that the period of the Cepheid variable stars are related to the intrinsic brightness. So this is super important. This law is called the Cepheid-Leavitt law. So as Pierre just mentioned, the classification system didn't get recognized for Annie's work, but luckily this is called the Cepheid-Leavitt law, so it's great that she got recognized for her work. And so this relationship is super important because it serves as a measurement, a way to measure the distance in this universe. So if we look up in the sky, we want to figure out how far away are those objects. We can't figure it out by just looking at them, so we need this relationship to help us. And this is a very important breakthrough in measuring astronomical distance, and we are still using the same method to measure distance today. And you may also heard of Hubble for his work, Edwin Hubble for his discovery that our universe expanding, and which you may also heard of the Hubble's law. That is so that the Hubble actually used the Cepheid variables as the yardstick to the universe, so he used the same method for measuring distance for his discovery. And also a very sad story here is that Leavitt got nominated for a Nobel Prize for her work. However, since the Nobel Prize are never awarded posthumously. So she died 4 years before she was nominated. So this nomination was withdrawn. Yeah, and Claire's gonna introduce Cecilia, another great female astronomer.
Yeah, okay, so we're moving into the 20th century now. Cecilia Kapashkin was the first person to earn a PhD in astronomy from Harvard, but it was officially issued from Harvard's affiliate female institution, which is called Radcliffe College. During her PhD, her work was to discover what the sun was made out of, and therefore what most stars were made out of. So she figured out that the sun was primarily made of hydrogen and also some helium, and therefore hydrogen and helium make up like most of the stars that we see, and therefore are the most abundant elements in the universe. And this was a huge breakthrough. Now it's maybe pretty commonly known that the sun is made of hydrogen and helium, but at the time this was not the expectation in the field. So when she was writing this PhD thesis, she encountered opposition from some of the most prominent astronomers of the day. And so this guy who worked at the Princeton University Observatory, whose name was Henry Norris Russell, was somebody who had a lot of opposition to this idea. At the time, it was thought that the sun should be made up of the same things that the Earth is made up of. So if you know your periodic table, you know that hydrogen and helium are very light elements, whereas the Earth is mostly made up of like rocks. And so it was thought that if you heated up the Earth to the temperature of the sun, you would get the exact same spectrum that is observed from the sun. And she showed that this is not true. But Russell convinced her to write that her results were, quote, spurious, and he only subsequently concluded that she was correct when a male astronomer reproduced her results using the exact same method that she had originally used. And this was a guy named Otto Struve, who called her work undoubtedly, this is a quote, undoubtedly the most brilliant PhD thesis ever written in astronomy. So yeah, this was pretty groundbreaking, and it's definitely still relevant today as we study the universe and the composition of stars. So Cecilia became the first female full professor in 1956, and then later the first female chair at Harvard in astronomy. And this is a particularly notable achievement because women students were not accepted into Harvard until 1977. So she really stood out as an incredible mind in astronomy. Okay, and then Nancy will talk about Jocelyn Bell Burnell.
So Jocelyn, she's another great astrophysicist. She was from the Northern Ireland. So she was known for her work to discover the first pulsar in 1967. So she was basically, she was studying the night sky, and she detected a rapid set of pulses occurring at regular intervals. So she determined that the position of these auroral radio sources remained fixed with respect to the stars. So which just means that these radio sources are located beyond the solar system. And then she continued her observation and found 3 more pulsating radio sources, and those are later found to be rapidly rotating neutron stars. So we have a great animation for you, so you can see this is a rotating neutron star, and you can see the variation in its brightness comes from its rotation. Like, so you can see the beams are pointing towards different directions. That gives you the difference in the periodic variation in its brightness. And So she actually, she was related to this controversy on the 1974 Nobel Prize in Physics. So when she was working on this project, she was working hard and reviewing as much as 96 feet of paper of this data per night, and she was facing skepticism from her advisor, PhD advisor at the time, who is called Hewish. He actually received the 1974 Nobel Prize in Physics for his decisive role in discovery of pulsars. However, it was actually Jocelyn who was really persistent in continuing this project, and even though Hewish at the time insists that it was due to the interference and the sources are man-made. So this was a big controversy, because if Bell didn't insist that this is a project worthy of more research, they could have just stopped and didn't continue in this. So on the right, you can see that was her first recognized evidence of a pulsar, now exhibited at Cambridge University Library. So it was sad that her work and her persistence didn't get recognized at the time, and Claire is gonna introduce you to another great woman astronomer.
So next we're going to talk about Vera Rubin, who contributed to the discovery of dark matter, which is one of my favorite topics in astronomy. She discovered something called the galaxy rotation problem. Basically, she was looking at faraway galaxies in the universe, and she was keeping track of how fast material was rotating at different points in the galaxies. And what she noticed was that kind of far away from the center of the galaxy, where you would expect that the stuff out there wouldn't be rotating very fast, it was going way faster than you would expect if you just counted up all the mass in the galaxy and used sort of basic laws of gravity to calculate its speed. And so it was almost like there was like a hidden amount of matter that we couldn't see in these galaxies that was forcing everything around way faster than it should go. And so the only explanation, along with some other observations that also pointed to the existence of this strange type of matter, was that there must be some type of matter out there in the universe, which was creatively named dark matter because it doesn't give off any light, that is a huge component of the universe, and there's actually more of this dark matter than ordinary matter. So this is a huge contribution, and still today we don't understand how dark matter works. We don't know what it is, and it's an active area of current research. So we are still trying to explain these original observations that Vera Rubin made. She overcame many obstacles to perform this work. So she tried to register for graduate studies at Princeton, but was barred because of her gender. This was in 1948. And they would not allow women in their astronomy graduate program for another 27 years after she tried to apply. She was also the first woman to use the Palomar telescope, and there's a fun little anecdote about that, which is when she started as the first woman using this telescope, at the observatory there was no women's restroom, only men's room. So she taped a little skirt onto the door on the restroom symbol and made it a women's restroom so that she could use it. Now, today, times have changed, and she's now the first American woman to have an observatory named after her. So the Vera Rubin Observatory was named in honor of her achievements. So that's pretty cool. And now coming to today, Nancy's going to talk about somebody here at UCLA.
Yeah, so this is Professor Andrea Guess. She's a professor here at UCLA, and she's the fourth woman to win the Physics Nobel Prize. So she actually is the first woman astronomer to win the Physics Nobel Prize also. So following Marie Curie in 1903, Maria Mayer in 1963, and Donna Strickland in 2018. So she won the Nobel Prize in 2020 for her work on the supermassive black hole at the center of our galaxy. So she shares the prize with Genzo and Penrose for their work in black hole formation and the evidence, the physical evidence for supermassive black holes. So before the Genzo and Andrea's work, we only have some theoretical theories for the existence of black holes and supermassive black holes, but we don't have much physical evidence available. But using adaptive optics, since 1995, Andrea has been looking at and her group has been looking at the center of our galaxy, and they were able to constrain the mass and the radius of that super compact object at the center of our galaxy, of the Milky Way, and they concluded that it could be nothing else but a supermassive black hole there. So this work now got recognized and got awarded the Nobel Prize.
And Nancy's continuing it today. So thanks for watching this portion of the talk. In particular, we would like to thank Elizabeth and Isabel here at UCLA for their help making these slides. We hope that you enjoyed celebrating Women's History Month with us and learning about these women who contributed to the development of astronomy. The second portion of this show is going to be a night sky showing. So do you want to switch it to... Yeah, so we're going to be using this program called Stellarium, which is a free computer program that you can download that allows you to look at the night sky anywhere in the world at any time. And so, okay, Nancy's going to start and talk to you about what we're looking at.
So what we are looking at right now is the night sky of Los Angeles. So you can see here, this is right now at Los Angeles on Earth, but we can't see much because we have the air pollution, the light pollution, and the extinction from the atmosphere. So if we wanna look at it, So if we want a better vision of what's happening, so we take the atmosphere away. So this now looks a little bit better than what you can see when you just go outside and look at the night sky. It's because we take away the atmosphere, and Claire's gonna
I'll
give
take
you a
over.
little more.
So when you look at this, you probably just see a bunch of little points of light, but people throughout the centuries have looked at the same view and seen patterns of stars called constellations that maybe resemble people from like their mythology or animals or objects. So using Stellarium, we can turn on the constellations and their names, and we can see that all across the night sky. So right now we're looking south, but all across the night sky there are groups of stars called constellations that make little figures. And so I'll just pan around so you can see some of these. You might recognize some of the names. right off the bat, I will point out some of the more famous ones. So over here we have Ursa Major, the Great Bear, and you may at some point have seen the Big Dipper, which is technically not a constellation, it's actually an asterism inside the larger constellation of Ursa Major, but it's formed by these stars here. So here's like the scooping part of the Dipper and then the handle. There's also a Little Dipper in Ursa Minor, the Little Bear, and the interesting thing about this is that at the tip of the handle of the Little Dipper, there's a star called Polaris, and this is our North Star. It's located above the North Pole of the Earth, and so as the Earth rotates through the night, all of the stars in the sky and the constellations appear to rotate around Polaris, and Polaris seems to be still. So another fun thing that you can do in Stellarium is speed up the time. So I can just kind of like start fast forwarding through the night. And this is what you would see if you were outside tonight for a very long time. But as you can see, all the stars are rotating around and Polaris is staying fixed in one spot. So that's pretty exciting and fun to watch. It's nice to like spend a night under the stars and you can actually see the movement of the stars throughout the sky. But I'm gonna go back a little bit. And then Nancy and I have also each picked out a constellation that we think is really exciting and we want to tell you more about. So I'm gonna start. When I was little, I really liked this constellation called Cassiopeia that you can see here. It's really bright and easy to find, and where I grew up in the Pacific Northwest is very high on the sky and easy to see, and it forms this W shape. So I always thought my last name starts with a W. I thought it was my little constellation. Cassiopeia also has a cool Greek mythology story. For those of you that are familiar with Greek mythology, Cassiopeia was a queen and she was extremely vain, and she claimed that she and her daughter, whose name was Andromeda, were more beautiful than the sea nymphs. And this really angered Poseidon, the god of the sea, who ordered that Andromeda has to be bound to a rock and eaten by a sea monster named Cetus. But then there was this hero, and he's also in a constellation, Perseus. My dog is named Percy after Perseus. So Perseus was a hero who saved Andromeda from the sea monster, and he ended up marrying her. But Poseidon was still mad at Cassiopeia for being so vain and boastful. So he condemned her to sit in a chair in the sky, and that way she is having to orbit around this Polaris pole star, and half the time she has to kind of like cling to the chair so she doesn't fall off. So I can also turn on in Stellarium a feature that we do not have in the actual night sky, which is pictures of what these constellations are supposed to represent. So if I turn on the pictures of the constellations, you can see here Cassiopeia is sitting in her chair hanging upside down, and yeah, there's this story, there's a lot of the characters in the sky. So we have Perseus here. Cepheus was Cassiopeia's husband. But yeah, it's a fun constellation. And then another fun fact about it is that in 1572, there was a Danish astronomer named Tycho Brahe, and he observed, along with a lot of people around the world, a supernova go off in Cassiopeia that was visible to the naked eye. And this was one of only 8 supernovae that were visible to the naked eye that survive in the historical record today. So the remnant of that supernova that Tycho Brahe observed is actually still visible if you have a really big telescope. So now Nancy will tell us about her constellation.
Yeah. So let's move to the southwest. So see here, you're looking at Orion, or the hunter in Greek mythology. And Orion, this is probably, everyone probably has heard of. It's super famous, and it's visible in the evening sky from January to April. And so here, usually how we find this is by the belt. So you can see these 3 stars here. We call it the Orion's belt. So usually we try to locate these 3 stars, and you can find Orion easily in the night sky. So tonight you can see it in the southwest sky. Probably later tonight is 10. So also, I want to introduce this star called Betelgeuse. So this is this is also called the Alpha Orionis. This is a massive M-type red supergiant star, and it's close to the end of its life. So we might see it dying one day. And it's actually the 2nd brightest star in Orion and the 6th brightest star in the night sky. It is also the largest visible star. In fact, we can fit 600 trillion Earth inside Betelgeuse. This is pretty amazing. Just like imagine 600 trillion Earth. This is super, super large. And another fun fact is that in 2019, in October 2019, Betelgeuse began to dim noticeably. And I remember I was in the observation astronomy lab class, and our instructors and basically everyone in the class were super, super excited, because it starts to dim, and by February 2020, its brightness became 1/3 of what it originally was. So astronomers were thinking, okay, it's probably gonna die and explode. It's gonna become a supernova. And we were super excited. We can witness this history of it going supernova. And but actually, it in February 2020, it stopped dimming and began to brighten again. And it's on February 25th, 2022, it actually came back to its normal brightness. So astronomers were confused, okay, what happened? And they looked in the infrared, and they found no significant variance in the infrared observations. So they concluded that, okay, there probably wasn't an impending core collapse happening, and the dimming was probably just due to some circumstellar dust that got in the way between us and Betelgeuse. But since we know Betelgeuse is probably dying and it's close to the end of its life, every time you go out and when you can see Orion, just pay some attention to Betelgeuse, because you may witness the history. You may see it explode and go supernova. It's super exciting. And also, another fun thing to look at in Orion is this nebula here. You can see here this nebula. So this is the Orion Nebula. This is very pretty, and this is visible to the naked eye in the night sky. And you can locate this by finding this belt, again, the Orion's belt, and south to it you can find this very beautiful Orion Nebula. And so pay attention to Betelgeuse and enjoy the beauty of the Orion's Nebula. Okay, I'm gonna hand over to Claire, and we're gonna talk about some more interesting features in the night sky.
Okay, so now we're going to look at an interesting feature of the night sky that is related to something you might have heard of. Oops. Oh, wait a sec. Where'd it go? This one. Yeah. Okay, yeah. So this yellow line that I just highlighted is called the ecliptic. If you remember kind of like your picture of the solar system, we have the planets all orbiting around the sun. And so this ecliptic line is like the path that the sun traces out as it as Earth rotates around the sun. So back in ancient times, people thought, oh, the Earth is sitting at the center and the sun is orbiting around it. But now we know that the sun is at the center of the solar system, and the Earth and the planets are all moving around it. So because of this, not only does the sun follow this line, but because the planets are all rotating around the Earth in the same plane or roughly the same plane as the Earth is rotating, the planets and the moon also always appear very close to this fixed line as well. And the ancient observers of the night sky noticed this, that there was this seemingly important kind of region of the sky where basically if you could see the stars in the daytime, you would see the sun slowly trace around this line over the course of 1 year. And as it traces through the sky, it will move through the region of the sky where 12 different constellations live. So these are, and you can see a couple of them here, these are Taurus, Gemini, Cancer, Leo. You can probably see where I'm going with this. These are the constellations of the zodiac. So we go from across to Virgo. So the zodiac are the set of 12 constellations that the sun passes through in the night sky. And if you could see the stars in the daytime, you'd see the sun moving through these constellations over the course of 1 year, making a complete circle every year. So ancient astrologers were able to figure out where the sun was on the zodiac by watching which was the last constellation of the zodiac to rise ahead of the sun, or the first to set after it, and then the sun was the one in between, in between. And so as such, each month one of these constellations had the title of the house of the sun, right, where the sun was. And so the year was divided up into these month-long periods, and each had like a sign of the zodiac. So that's where the zodiac signs come from. But a fun fact is that if you go to a newspaper and you read a horoscope for the zodiac sign for your birthday, right? So I go and I'm born in early November, so my zodiac sign is Scorpio. This sign is not actually where the sun was for that particular month when you were born, but where it was several millennia ago when the zodiac was first created. So because the Earth tends to wobble slightly on its orbit around the sun, what scientists call precession, the location of the ecliptic with respect to the stars that we see in the sky shift a little bit over long periods of time. So the zodiac used by astrologers today is based off of a millennia-old system of observing the sky. Okay, and now Nancy will show us our galaxy.
Yep. So now let's change this coordinate.
You can go here.
Oh, here.
Yeah, that one.
Okay. Thanks. Now look at the galactic equator, and oops, let me close this. And you can see this orange line here. Let's get rid of the constellation lines for the moment and the pretty arts. So now we get a clear view of this line. So this is the galactic equator. So as you may know that our galaxy is a spiral galaxy. It's like a desk laying on a plane. So this galactic equator gives us the plane of our galaxy, our Milky Way. So let's travel in time again. So it's a nice and interesting feature of Stellarium that it allows you to time travel, basically. So let's now travel to, say, September. And let's look at our Milky Way. So as I mentioned before, that see it rise. Actually, we are going back. So, yep. Oh, nope. Okay, let me see.
No, you just set it back to March.
Oh, yeah, that's great though, because we didn't mess up the hours. Okay, great. So now we are looking at our Milky Way, since it's a disk, or because it's a spiral galaxy, and we are basically sitting at one of its spiral arms. So when we look at the center, we are so that's adjunct. We are looking at this basically a line in the sky, a bright line in the sky. So the ancient Greek, I think it's a spelled milk, so they call it the Milky Way, right? So now let's look at this beautiful Milky Way, and we just mentioned before Professor Andrea Guess for her work looking at the galactic center. So we know the supermassive black hole is somewhere here. So this star actually is called Sagittarius A. So let's go to this black hole. Oops, is it? It's probably my computer not happy. Sagittarius A. Interesting. Let me see if I can try to Sagittarius. It's probably too challenging to me. Okay, so basically we have this in the constellation Sagittarius. You can see the archer here. So since this star is located in the constellation Sagittarius, it's named Sagittarius A Star, and the convention here is because it's not a star, so we add a sign, a star to it. So it's actually not a star, but by convention we add the star to tell people that it's not a star. Okay, and so Andrea, and the Galactic Center group here at UCLA observed with adaptive optics systems the galactic center, and found that there's a mass of 4 million times the mass of our sun, compressed into a region smaller than 40 times the distance between the Earth and the sun. So they use the Kepler's law to constrain the mass and the size of that compact object. And with some more analysis, we conclude that it could be nothing else but a supermassive black hole in there. So this provides the first physical evidence of the existence of supermassive black holes. And UCLA, the Galactic Center group, is now doing active research to understand the galactic center. And they are using this the region close to the supermassive black hole as experiment field for theories like general relativity. So people can test general relativity at this with this region with this supermassive black hole, and yeah, I
Do you
think.
want to go back to the video so they can see?
Oh
our faces?
yeah, just one sec. I wanna do my last try on getting our. Oh, it worked. Yeah, perfect. So now you're looking at this little spot here. You can't really see anything because it's a black hole, but there are a lot of stars. There are some old stars and some new stars that we can find a proper explanation for right now, orbiting this supermassive black hole. And yeah, this is our galactic center. And yeah, let's go back to the video and.
It's
Uh,
down there.
yeah, let's go back to the video. Great.
Okay, so that's the end of what we had planned tonight. Thank you for watching our show. If you enjoyed the night sky part of this presentation, we recommend that you can download Stellarium for free and explore the night sky for yourself. Hopefully you saw that there's lots of interesting objects to look at. Or maybe go outside and try to find some of these constellations yourself in the sky. So the next academic term at UCLA, we may have in-person shows again. So check back in for the possibility of watching future shows back at the UCLA Planetarium, like in the real dome, which is also very fun. And then keep checking the Planetarium website for all the upcoming shows that are planned. So, yay,
Yeah,
thank
that's
you.
it. Thank you.